Hello guys, welcome again to the channel. My name is Amos from Acoustics. So as requested by one of our viewers in the other video that I did, we want to transform this room into a recording studio, a usable recording studio by setting up, just as you can see here. As I promised also in the other video, this is the front area. The rear wall is right behind there. So the length is 14 feet, the width is 9 feet, and the height is 10 feet. So the height is not so bad, but it's still a small room. So the idea here is to control that reverb that you hear in this room, because if we work in a room that sounds like this, then we don't get the exact sound that comes from the speakers, or in case we are recording, we cannot get the exact sound as from the voice or as picked by the microphone. So we want to reduce that distortion that is caused by the reflections of the wall and the ceiling. Just to see how well these panels are able to work, and encourage other guys who work in rooms that sound like this, that indeed you can invest in acoustic treatment and it's worth the money. So the idea is to take this measurement here. This is a microphone that is used for acoustic measurements. It's calibrated, and by that I mean it comes with a calibrated file. So the purpose of that calibrated file is to correct the problem that the microphone has in terms of frequency response. So if the microphone has a problem at a specific frequency that is not so linear, or it's boosted, then the calibration file will take care of that during the analysis, so that we get even response across the spectrum, so that the result that we get out of that is credible result. So what we want to do is set this microphone right in the middle where we are sitting, right where the chair is. So the distance is equal between the two speakers, and also equal between the two speakers and the microphone. It's the equidistance, which is where we're going to set up the sitting area. So the next step is to just set up and take the measurement and share with you the measurement before and after, so you can see how good these panels can be able to transform the sound. Also, we are going to share things like RT60, RT20 or RT30 readings. We're going to share spectrogram analyzer. We're going to share things like waterfall graph and frequency curve of the room before and after, so you can see how well these panels can be able to make the room sound better. Also, all the panels, most of the panels are 6-inch panels, and a few of them are 8-inch panels. So the 8-inch panels are going to be used right behind the speakers. Behind the speakers right there, the front wall. And then the rest of the area will have 6-inch panels, and some few 4-inch panels at the back. And also we are going to include things like scatter plate in a later stage of this video, just to be able to demonstrate the purpose of scatter plates and diffusers as we go on. So stay tuned for that, and let's start. Let's take the measurements and see how it goes. Okay guys, I've already set up the microphone at the center, and that means it is equidistant from all the two monitors to make a triangle. So this is going to be the sitting position where we'll be sitting. So I'm going to take the measurements, and before that I'm going to click to check the levels, as the software is requesting that we check the levels. If the levels is too low, it will show us to adjust the levels. If the level is so high or it's recommended, it will just suggest the level is okay, then we just press proceed. After that, I'm going to leave the room and just let the software do its work, because if I'm here in the room with the measurement, then I'm going to also interfere with the measurements, because we want to take the measurements of the room without anything that's absorbent. So let's do that. So the software says the level is okay, so we are okay to proceed. Hello guys, moment of truth now. This is the studio after the treatment. Already you can hear the audio is quite clear, because these panels have been able to drastically reduce the reverb time. And as I mentioned earlier, these are panels from the other side are 6 inches thick, and they have 4-inch air gap behind them. They are freestanding, by the way, and the other side the same thing. And the rear wall, we have another 6-inch panels that are directly on the wall, because also we are supposed to do some diffusion, which we'll talk about later on the rear wall. And then the other side, which is the front wall, we have behind the speakers, we have the broadband absorbers, the corner bass traps, which are 6 inches, and then we have another 6 inches thick air gap behind them, both sides. And then right behind the screen, you can see two very big panels right there. They're very thick. They're 8 inches with another 4-inch air gap behind them. So we want to take another measurement and just A/B before treatment, after treatment. And also I played a song before the treatment, and I'm going to play that song. That very song is a very popular song after the treatment, so we can A/B and hear the difference that acoustic treatment has made. So let's get to the measurement and just take the room EQ wizard and take the measurement using the same spot which I already marked on the floor. So the microphone is going to be at the exact same position where it was before the treatment. Hello guys, now it's time to analyze these readings that we just took between treated and untreated room, because that will show us the effect of these panels other than just depending on our ears alone, because there are certain areas of audio that our ears cannot be able to tell clearly, and that's why we are going to depend on this software here to just enable us understand what's going on in the room after the treatment. So we have the interface here of Room EQ Wizard, and then on the left side we have the signals as recorded by the software, the red one showing untreated room, the green one showing treated room. So we are going to look at it and we are going to look at these areas here, just around 3-4 areas. So we're not going to explore the whole of Room EQ Wizard right now. We are going to focus on all SPL, which shows the frequency curve before and after the treatment, and then we are going to show waterfall graph, which shows the decay time for the frequency spectrum, and also we are going to show waterfall graph and spectrogram analyzer to show us just the image of what's going on in the room that we cannot tell using our ears. Another thing that we need to look into is the RT20 or T20 decay time in the room before and after, which is the reverb time before and after the treatment. So let's start with the all SPL, which shows the frequency curve before and after. So we can see then and start from the lowest, we have the effect here at around 30 hertz. So we had a very sharp dip there. When you are going to see a dip in this kind of readings, it means at that position that signal was not audible. It is attenuated, it's reduced. Then when we apply the acoustic treatment, then you can see the green line is trying to bring it up and make it a bit audible. So it means we can now hear a bit of that 30 cycle, 30 hertz, a bit of it at the sitting position. Then from 30 hertz all the way from around 40 area, 35 to 40 area to 45 all the way to 50, we don't have anything going on there, because those are also axial modes which require different type of absorbers, which is pressure based, which we don't have in this case. We are purely working with porous absorber. So we can see 50 hertz also, there's a very big dip there, 50 to 55, that has been corrected by the green signal, and that's good because you can hear a bit of 50 hertz now from our sitting position, which is a great thing. Then from 55 all the way to around 60, not so much difference is going on there. And then from 60 to around 70, we have also corrected dip there by the green signal, which is great. So we want to make it a bit simpler and a bit quicker. So as we proceed from there all the way to the highest frequencies around mid area, lower mid area, which is around from 70 to around 120, we have a very decent correction there. Also there's a dip that has been corrected by the green signal. So generally when you look at the green signal, it's trying to correct the problems or the dips and the peaks that it's there. So let's continue and just work with the same smoothing, which is 1/48 for both the treated and untreated, and just see what really happens. So we are using treated and untreated, and the smoothing is 1/48. So let's see, you can see the green line is trying to smoothen things out. The red one is a bit wavy, and that shows the peaks and troughs, which is what we call room modes and things like reflections going on inside the room. So that is how we look at it. So generally the green line is trying to correct that as shown there. So to make things a bit straightforward, let's move to the next, which is the waterfall graph. So waterfall graph actually shows the decay, the time it takes for this signal to decay in the room before, and you can see before how the signal looks like, and after it's been reduced drastically. So how you read this this graph is that it has 3 axes, that x-axis, the y-axis, and the z-axis. So the most important actually is the z-axis because it's showing the decay time. So it's coming towards the screen as shown there in the screen. So if you can look at before, from around 50 hertz area to around 200 hertz area, you can check the decay curve there, and then after you can see the reduction there. So the reduction is a bit is not so bad, it's drastic. It makes audible difference between treated and untreated room. And then we have another option of around the lowest frequency all the way to 20 kilohertz, which also we can check between treated and untreated, and you can see that the reduction is so massive all across the frequency spectrum. So it means these panels have been able to really control the reverb in this room and manage parts of the room modes that are causing problems in this room. So that's how we look at it before and after, waterfall graph, treated and untreated. You can see that difference there is very clear. And then the next one, we need to look into spectrogram, which also shows decay time within the room. And we can look at before treated, and that is from around 50 hertz all the way to around 4 kilohertz, which is our main interest in this case. So let's look at it, and you can see it's very shaky, it's wavy before treatment, and then after treatment you can see it's been smoothed out. So we have, it's a bit linear, and that is what we hear between treated and untreated room. So another thing that we need to look into really quickly is the T20. It's not supposed to be T60 because T60 is for large rooms, so we don't have enough reverb that can warrant us to use T60 in small rooms. So in small room we need the signal to decay by 20 dB, because if say what it to decay by 60 dB, it means the room needs to be very large to decay by 60 decibels. So in this case it's T20 as shown here by the software. So let's go at the overlays and just look at the T20 readings, others known as T60 in the acoustic world. So let's look at it. We can see also at the reverb time is reduced, not so much from the 50 hertz area, but it is from 1.8 seconds to around 1 second. Not bad, but also not very good, because the room is kind of a bit small. We still have room modes to deal with in this case. Then moving next, we have around 60 hertz, which has been reduced from around 2 seconds to around 700 milliseconds, a pretty decent reduction. And then from there we go to around 70 to 80 area. We still have a reduction of 900 milliseconds to around 200 milliseconds. So these panels have started working very nicely around 70 hertz area, because that's now where we have very massive reduction in room, in reverb time. And then from there all the way now to the high frequencies, as you can see here, we have very big reduction in reverb time. So it means the panels have been able to do really good job, considering we only have around 10 of them in this room. So that's how we look at it. So the next thing we need to do is now to play a song that I played earlier and just hear real world acoustics, how these things are able to transform the sound of the room before and after. So I'm going to play this song and I'm going to chop it in segments where some parts are treated and some parts of untreated room, and I'm going to show that to the text. So if you have any suggestion, you can comment down there. Meanwhile, if you find the content interesting, you can like and also share and subscribe for more of this kind of content. So this is just the first part of the video. The second part, we are going to talk about things like diffusers and scatter plates and the effect they have in rooms like this one. So stay tuned for that. So for now, like, share and subscribe. Thank you for watching.